Down there, life continues. The traffic is awful, stocks go on trading, and Star Trek is still showing. Down there, life continues. The traffic is awful, stocks go on trading, and Star Trek is still showing.
Hello, grade 9 learners. Welcome to today's natural sciences lesson. My name is Mr. Sianda Madala, and this lesson is proudly brought to you by the Gauteng Department of Education. Right, today we're going to look at series circuits. Remember, on our last topic, we were talking about what? Resistance and uses of resistors and factors affecting resistance, right? So today I want us to look at a type of a circuit which is series circuit, and this topic is found under the main topic, series and parallel circuits, right? Remember, it's term 3, we're dealing with energy and change. So let's dwell more on these series circuits. But firstly, let's look at what we need to achieve by the end of this lesson. Let's look at the lesson objectives. Right. By the end of this lesson, you should be able to explain that the voltage across the battery is equal to the sum of the voltages across each of the resistors in a series circuit. Are we together? Secondly, you need to be able to explain that a resistor with a higher resistance will have a higher voltage across it. And also you need to be able to know and explain that a resistor with a lower resistance will have a lower voltage across it. Are we together, grade 9s? Not only that, right? You need to be able to state that the current is the same when measured at any point in a series circuit. It is the same at any point in a series circuit. And also, you need to be able to state that current is measured using an ammeter, right? It is measured using an instrument called an ammeter. And also, you need to be able to explain that ammeters are always connected in series because they have a low resistance. Then lastly, you need to be able to explain that the current in a series circuit, it does what? It decreases with every resistor added in that circuit. And all this information is found under the KEBS document on page 73. Let's move on. Now let's look at what we have done in the previous grades and the same grade prior to today's lesson. So in grade 5, we have done electric cells, right? And in grade 6, later on, electric cells were reintroduced again, right? We have done an introduction to electric cells in grade 5 and grade 6. And also in grade 6, we have talked about mains electricity. Not only that, we talked about now in grade 7, the supply system. Not only the supply system when it comes to electricity, but the national electricity. We have talked about that one as well. Then lastly, in grade 8, we talked about the energy transfer in electrical systems. That's what we have done as foundation to today's lesson, right? And I hope all of this comes up when we proceed with the lesson, right? So now, here is a baseline activity. I want us to test ourselves using this baseline activity. It has 4 questions, right? So I'm going to give you 4 minutes, right, to answer this baseline activity. But first of all, let's go through the questions together. Number 1, it says, is a voltmeter connected in series or parallel, and why is it so? Right? You need to tell us whether a voltmeter is connected in series or in parallel and the reason to your answer. Then number 2, state what happens to the current in a series circuit when we add more resistors. You need to tell us that, right? What happens in a series circuit when you add more resistors? Number 3, what is the unit of measurement for current? Then number 4, define resistance. That's what you need to do for your baseline activity. 4 questions and 4 minutes. Let's meet again after 4 minutes. Welcome back, grade 9 learners. Now, I hope you have enjoyed our baseline activity, right? I hope you were able to answer our questions. And now, in order for us to see whether you were able to answer our questions or not, we have our WhatsApp interactive number in which you can contact us, right? To send us through your answers, questions, or comments about this lesson. The WhatsApp number is 079 578 2908. Are we together? So now, let's look at the solutions for our baseline activity. Number one was saying, is a voltmeter connected in series or parallel, and why is it so? And the answer is what? The answer is that a voltmeter is always connected in parallel, right? This is why. This is because a voltmeter has a very high resistance and prevents the flow of current, and that's why we have to connect it in parallel. Number two, state what happens to the current in a series circuit when we add more resistors. What happens, right? This is what happens. It will decrease, right? As you add more resistors, the current will decrease because now they offer more resistance in that series circuit. Number three, what is the unit of measurement of current? Current is measured in what? In amperes, right? Which is abbreviated as A. Then number four, define resistance, right? We did this last week, right? So how can we define resistance? Resistance is defined as what? As a force that opposes the flow of current in a circuit, right? Now give yourself ticks for those correct answers, right? If not, I will give you time, about 1 minute, so that you are able to copy down the corrections. So now it is very good so that you write down the corrections in order to correct yourself, right? So now take a minute so that you can write down the corrections. Welcome back, grade 9 learners. Now we have done writing our corrections. Now I want us to proceed smoothly with our lesson, right? But before that, we need to introduce the important terminology that is associated with this lesson, right? The first one there is what? Series circuit. Now, what is a series circuit? A series circuit is an electric circuit that has only one pathway for current to pass through, right? It is an electric circuit that has only one pathway for current to flow through. And we have another one here, which is current, right? Now, what is this current? Current is the flow of electricity or the flow of charge through a conductor. We then have what? Ohm. What is an ohm? An ohm is a unit to measure what? Resistance, or it's a unit of measurement for resistance. Are we together? Now, let's look at the following ones. We have also ammeter. And an ammeter is defined as an instrument for measuring electric current in amperes. We also have what? Parallel circuit. What is a parallel circuit? A parallel circuit is an electric circuit that has more than one pathway for current to flow through. Are we together, grade 9? So now, moving on to the main meal for today, series circuits. What did we say a series circuit is? We said that a series circuit is a circuit in which the current follows one direction, right? Or it follows one pathway without branching, right? It only follows one pathway and the components are connected one after the other, right? Because it only follows what? One pathway for electricity to flow through. Here's an example of a series circuit. It has a battery, a light bulb, and a switch, right? So this is an open switch. It means now it is cutting off the electric charge, right? But if the switch was to be closed, what is going to happen now? There's going to be flow of electric charge, right? But look at the flow of charge. It follows one pathway. It doesn't branch into other pathways, right? Because it is a series circuit and the components are connected one after the other. So it follows that one pathway throughout, right? And also, the direction of conventional current flow is from the positive terminal to the negative terminal of the battery. So meaning what? Electric charge will flow from the positive terminal of the battery back into the negative terminal of the battery and along that one pathway in a series form. Are we together? So now, we know a little bit about series circuit. We know what a series circuit is. So I want us now to focus on connecting cells in series. What happens when we connect cells one after the other, right? What happens? This is what happens. When we connect cells in series, we connect the negative terminal to the positive terminal of the following cell. As the statement says here, right? We connect cells in series by connecting the negative terminal of one cell to the positive terminal of the next cell. Does it make sense? Now remember the what? The circuit symbol for a battery or a cell, right? Which one between the two? In last week's lesson, we said that the long arm is the positive terminal and the short arm is the negative terminal. And in this case, we are saying when we connect cells in series, we connect the negative terminal of one cell to the positive terminal of another cell. Are we together? So this is how, right? This is the positive terminal of this cell and the negative terminal of this cell, right? So it is one cell at this case. But now we're connecting cells, meaning two or more in series. We have to connect now the negative terminal of the first cell to the positive terminal of the following cell, right? So here's the following cell. It has its positive terminal and it has its what? It has its negative terminal. Are we together? So in this case, this is a battery because now we have two cells, right? This is one cell. The negative terminal of each is connected to the positive terminal of the following cell. That's how we connect cells in series. Now, don't forget that part, right? It is very much of paramount for you to grasp this part, right? The negative terminal of the first cell must be connected to the positive terminal of the next cell when we're connecting cells in series. So now, a question might arise in your mind, right? What happens when you connect now these cells, as we said, as you connect cells in series? What happens? So when they are connected in series, the total voltage of the battery, right? Remember voltage we talked about last week, the potential difference, right? The total voltage of the battery is the sum of the individual cells. What do we mean by that? We mean that we add the cells connected, or we add the voltages of the cells connected to give us the whole what? Voltage of the battery. So the more cells you connect in that series, the higher the voltage of the battery. The voltage increases. Let's look at this example, right? For instance, one cell here has what? Or each of these cells have 1.5 volts, right? That is one cell. So now we have how many cells here? We have 3 cells. And we just said that when you connect cells in series, the total voltage of the battery is 2 or more cells, right? So the total voltage of this battery will increase, and it is the sum of the individual cells. What do we mean by that? We simply mean that as each of these are 1.5 volts, it's going to be 1.5 plus 1.5 plus again 1.5, right? It gives us how many volts? It gives us 4.5 volts of the battery in total. Meaning the potential difference in this circuit is what? It is 4.5 volts. Because now, It is what? It is the sum of the individual batteries or the individual cells. Are we together? And trust me, we're going to investigate that further, right? As the following slide says, we're going to investigate now the effect of connecting more cells in series, right? We're going to go through an investigation together. So now, if we're going to investigate the effect of connecting more cells in series, right? What is our aim? Let's look at our aim now for this practical investigation. The aim is to investigate the effect of connecting more cells in series. So what would be our hypothesis here? Our hypothesis is what? The more cells you connect, the higher the voltage of the battery, right? So now we're trying to prove whether this is true or not, right? So now what do we need to do that, right? The apparatus, right? What apparatus do we need? We need a circuit board or cell holders. We need cells, right? We need 3 cells to test this out. And we need 2 identical light bulbs or LEDs. We need a voltmeter so that we can be able to measure the voltage across the battery, right? And we also need conducting wires. So the question is now, how are we going to do that, right? The method, right? Firstly, we're going to set up what? A series circuit with 1 cell and 2 light bulbs in series. Then secondly, we're going to connect the voltmeter over the terminals of the cell and record the reading, right? Then note the brightness of the bulbs. Then you should have a question in your mind to say, what does the brightness of the bulb tell you about the circuit? Then number 4, we're going to repeat steps 1 and 2 with 2 cells connected in series. Now we're adding another cell, right? Then connect the voltmeter also to check the volt or the voltage across the battery. Number 5, we're going to repeat also steps 1 and 2 with 3 cells now, right? So the fact of the matter here is to check the effect of cells as we add them in a series circuit, right? We're going to start off with 1. We're going to add another 1. We have 2. Then we're going to add another 1. Then we have 3. So now we need some time to prepare, right? I'm going to give you 5 minutes so that you prepare as well. And I prepare and go to the lab so that I can show you this experiment, right? So 5 minutes it is. Welcome back, grade 9 learners. Now we are back in our lab, right, to do this practical investigation. Remember, our aim is to check the effect of what? Adding more cells in a series circuit, right? So now, we have what? 1, 2, 3 cells. Are we together? We have 3 cells, we have 2 light bulbs, we have conducting wires, and also we have our voltmeter and the circuit board, right? So now step 1 was saying set up a series circuit with 1 cell and 2 light bulbs, right? That's what we're going to do now, right? With 2 cells and one cell and 2 light bulbs, right? So here are the 2 light bulbs, right? They are connected in series, they follow each other. Then we connect our main source of energy, right? 1 cell. So now, remember, the positive terminal must be in the positive terminal of the cell. And also, we are going to check what? Our brightness here, right? So, let's look at this. What happens now? Right? Now, check this, right? It is somehow a bit bright. Né? It is a bit bright. But remember, we need to check the voltage, right? That's why we have this voltmeter here, right? And check the reading of this voltage in this cell, right? So positive terminal to positive terminal and negative terminal to negative terminal, right? So now, yes, right? Here it is connected, right? Now, can we see our reading here, right? Yes, can we? Yes, right? Now, let's record our readings here, right? Let's record our readings, and also you do the same, right? You do the same on your side. Are we together? So now, step number 2, right? We have connected the voltmeter and we've recorded down what? The reading. Then step number 3, it said what? Notice the brightness of what? Of the light bulbs, right? It is a bit dim, right? But it is lit. Yeah? Then number 4, we need to repeat steps 1 and 2. Now we're connecting what? 2 cells. Now let's disconnect this first. Then we connect 2 cells and see what is going to happen, right? Remember our hypothesis as well. This is the second cell connected in our series circuit, right? So now let's notice what happens also to the brightness of the light bulbs. Are we together? So now, also we need to measure the voltage, right? Connect the voltmeter in parallel to the cells, right? We connect the voltmeter in parallel to the cells. Now let's look at the reading there, right? Are we able to get a good reading? And we should record it down, right? We should record it down, right? Write it down as I'm writing down as well. So now, let's move on. We're going to repeat steps 1 and 2 now by connecting 3 cells in series, right? This is our third cell. We're going to connect, right? So now, let's look at what happens to the brightness of the light bulbs. Wow, right? It's becoming more bright as well, yeah? So now, let's look at the readings as well, right? Let's look at the readings of the voltage, right? By connecting this voltmeter, right? Look at our reading there, right? It keeps on, right? It keeps on increasing, right? So now, record down your readings as well. Right? You record down your readings, right? Are we together? So now, after recording down your readings, I want us now to take about 2 minutes so that we can clear everything up and we go back to our lesson. Welcome back, grade 9s. Now I hope you have enjoyed our practical investigation, right? Remember, we're waiting for those answers, we're waiting for those recordings that you have done, right? Our WhatsApp number is 079 578 2908. Now moving on with our practical investigation, right? You need to write down the observations, right? So you need to complete this table to record your observations. Remember, I said that you should note them down, right? As you have noted them down, you just write them here and fill in the table, right? So it takes about 2 minutes to do such, then take 2 minutes to complete this activity. Welcome back, grade 9 learners. Now, before we continue to look at the solutions, right, we have an interesting question coming from our learners from Jimiston High School, right? So now the question was, what is resistance? Remember, resistance is an ability of a component to oppose the flow of current, right? Are we together? So I hope I've answered your question very well. Né? So now, let's move on and look at our solutions for the observations, right? So now, we had what number of cells? When you connected one cell, what happened? What was the voltmeter reading, right? The voltmeter reading was 1,4, right? It was 1.4. Now, as we added the second cell, what happened? The reading was now 2.7, right? The total reading of the battery was 2.7, right? And as we added the third one, we found out it is what? 9,1 volts, right? And as this happened, also the brightness of the light bulbs was increasing, right? So when it was 1.4, it was just bright, but that dimming, right? So now, when we added two cells, it was not 2.7 volts, and it became brighter because of what the current strength increased. And it was 9.1, it was at its brightest point because now the current strength increased more. Are we together? So now, our conclusion is that the more cells you connect, the higher the voltage of the battery. Are we together, grade 9s? Let's move on. So now let's talk about connecting resistors in series. What happens when you connect resistors in series? This one also needs you to listen attentively, right? So resistors can be connected in series in a circuit, meaning they can be connected to follow one another, to follow one pathway, right? So what happens when you connect these resistors in series? First of all, a light bulb is a type of resistor as well, right? Because it opposes the flow of current. And here's an example of light bulbs connected in series. As you can see, they follow one pathway and they are one after the other. Are we together? So the unit of measurement for resistance is ohms, right? It is ohms. So now what really happens when you connect these resistors in series? The total voltage across the battery is equal to the sum of voltages across each resistor in the circuit. What do we mean by that? Let's look at the diagram below, right? We simply mean that the total voltage of the battery is made up by the sum of individual resistors in that circuit. Are we together? Looking at the diagram here, where is the battery? Let's remember our symbols. Where is the battery? This is the battery, right? So we're meaning that the total voltage of this battery is made up by the sum of the individual resistors in that circuit. How many resistors do we have here? We have resistor 1, resistor 2, resistor 3. It means now, to get the total voltage of the battery, we need to calculate each and every resistor or its resistance by doing what? By adding them together, right? By adding resistor 1, resistor 2, and resistor 3 to give us the total voltage across this battery. Are we together? And now, the same goes for calculating of what? Resistance in a series circuit. The total resistance in that circuit is the sum of individual resistors in a series circuit. Are we together? So now, who can guess the total resistance of this circuit? By looking at resistor 1, resistor 2, and resistor 3, right? Let's think about it for a few seconds. Who can guess what? The total resistance of this whole circuit by looking at resistor 1, resistor 2, and resistor 3. Are we winning or are we losing, right? So now, should I help you? Right. Remember, I said that the total resistance in a circuit is what? Is the sum of individual resistors in that series circuit, right? So now, if you look at resistor 1, it has 2 ohms, right? It has 2 ohms. Are we together? Resistor 2 has what? 3 ohms. So we're going to say plus 3. Then resistor 3 has what? 4 ohms, right? Then we're going to say plus 4. So now what is our total resistance? It is 2 plus 3 plus 4, right? So 2 plus 3 is 5 plus 4 it is 9. So what is our answer? Our answer is 9 ohms. Are we together? It is 9 ohms. That is our total resistance for this series circuit. I hope we're getting this grade 9. Moving on. To illustrate more and emphasize more, we said that the total voltage across the battery is the sum of individual resistors in that series circuit, right? So let's identify the battery here. The battery is this one, right? Which has what? 6 volts. And as the total voltage is the sum of individual resistors, let's look at individual resistors there. You have how many light bulbs there? You have one light bulb and you have another one. Are we together? So you have 2 light bulbs. But when you look at these light bulbs, they are 3 volts each, right? It is 3 volts on this one and 3 volts on this one again. So what does it say about the total voltage across the battery? It is 3 plus 3 to give us this 6 volts of what? Of total voltage across the battery. Moving on. We said that a resistor that has a what? A higher resistance will have what? A higher voltage across it, right? As it has more resistance, it will have higher voltage across it because it is what? It is working against a lot of electrons, right? As it is trying to resist the flow of current. So as it has more resistance, it's going to have higher voltage across it. And a resistor which has a lower resistance, it will have a lower voltage across it as well. And the current anywhere in the series circuit will be the same. So meaning if we were to measure current in a circuit or at any point in a series circuit, it will be the same. The reading that we get from ammeter 1, it will be the same as the reading that we get from ammeter 2. Are we together? Also, the current in the series circuit decreases with each resistor that is added. The more resistors you add in a series circuit, the more the current decreases, because now there's more opposition of flow of current. And we can measure current with an instrument called an ammeter, right? And the unit of measurement for current is amperes, as we have said. Are we together? So an ammeter is always connected in series because it has a low resistance, right? It is always connected in series. So who can identify an ammeter here, right? Who can identify the component ammeter in this series circuit? Yes, we have a battery. The others I don't know. Who can identify an ammeter? Yes, the ammeter is this one, right? Which is abbreviated as A. That is our ammeter, and the other one is the light bulb. So now, here we have activity 1 now, right? We have activity 1. So it is 2 questions, and I'll give you 2 minutes to answer activity 1. First of all, let's go to the questions. It says, what do we know about the current strength at any point in a series circuit? Then number 2, what do we know about the total voltage across the battery of a circuit with resistors connected in series? Let's meet again after 2 minutes. Grade 9s. I hope you were able to answer these ones as well, right? So let's look at the solutions. Number 1 was saying, what do we know about the current strength at any point in a series circuit? What do we know about that? We know that it will be the same, right? Whether you measure it at any point in a series circuit, it will be the same. And number 2 is saying, what do we know about the total voltage across the battery of a circuit with resistors connected in series? And we said that the total voltage across the battery of a circuit with resistors connected in series is equal to the sum of the voltages across each resistor. Are we together? So now let's just take a quick minute to write down the corrections, right? After 1 minute, we'll meet again. We are still waiting for those answers, those comments or questions on our WhatsApp line. Don't forget 079 578 2908. Now, I hope you had enough time to copy down the corrections and you are ready for activity 2. Let's look at activity 2. Also, activity 2 is 2 minutes. So I'm going to give you 2 minutes, but firstly, let's go through the questions together, right? Number 1. What happens to the current strength when more resistors are added in a series circuit? Right? And also, number 2. What do you think will happen to the brightness of a light bulb if another light bulb is added in series? That's all that you need to do for activity 2. So don't forget, take 2 minutes quickly, then after that we can recap. Welcome back, grade 9 learners. Now let's look at our solutions for activity 2. Number 1 was saying what happens to the current strength when more resistors are added in a series circuit. What happens, right? The current decreases as more resistors are added, right? The current decreases. Then number 2, what do you think will happen to the brightness of a light bulb if another light bulb is added in series? What will happen here? The brightness of the light bulb will also decrease, right? The brightness of the light bulb will also decrease. So now let's just go through these answers again so that you have enough time to copy down corrections, right? Number 1, the current decreases as more resistors are added. And number 2, the brightness of the light bulb will decrease, right? So I hope you got enough time to copy down the corrections and ready for activity 3. Don't get tired, lovely grade 9s, right? The more you write activities, it's the more you understand the topic, right? So now, this one is kind of tricky, right? It has a scenario, it has the diagram, and it has questions, right? So I want us to go through the scenario together and everything together. Then I'll give you 4 minutes after that to answer the questions. So now, the second diagram below shows a battery, 3 resistors in series, which is resistor 1, resistor 2, and resistor 3, and 2 ammeters, ammeter 1 and ammeter 2. There is a voltmeter connected across the battery as well as across each of the resistors. The reading on ammeter 1 is 2 amperes, as abbreviated as 2A, right? The potential difference in resistor 1 and resistor 3 is 1 volts each. And here we have a diagram, right? Then number 1 says, what will be the reading on ammeter 2? Give a reason for your answer. Then number 2, the reading on the voltmeter across the battery is 4 volts. Calculate the reading on the voltmeter across resistor 2. It's kind of tricky, right? Because it needs your understanding and it has calculations. That's why I'm giving you lovely 4 minutes. Then after 4 minutes, we can meet again. Activity, right? And I hope you were able to answer the questions, right? If you want us to view your answers, send them through to our WhatsApp interactive number, right? So now let's look at the solutions. Number 1, it is what? 2 amperes, right? Because the current is the same at any point in a series second, right? The current is the same at any point in the series circuit. And where do we get this 2 amperes? It is right there in our scenario, right? So now number 2, here are these calculations, right? We're looking for what? For the reading of what? Of resistor 2, right? So of voltmeter 2, right? So now, because we have 1 and 3, this is how we substituted, right? Total voltage is equal to voltmeter 1 plus voltmeter 2 plus voltmeter 3. And the substitution is what? 1 plus V2 plus 1. Because the ones we already know from our scenario, right? So it is 1 plus V2 plus 1. So this 1 plus 1, it gives us how much? It gives us 2, right? Plus the V2, because we know the total voltage across the battery as 4 volts, right? So this 2 from this 1 plus 1 gives us what? 2 plus V2 that we are looking for, right? Then we cross multiply, right? So what happens? It is 4 minus 2. The sign changes, right? The 4 minus 2 now gives us what? Our V2. And our V2 is 2 volts, right? So therefore, what we're looking for is 2 volts as our answer. Are we together? It is 2 volts. So now I hope you have enjoyed this activity, right? So now I want us to summarize what we have learned for today. Today we were talking about series circuits. We said that a series circuit provides only one pathway for the current to flow or to pass through, right, without branching. And resistors can be connected in a series circuit, or they can be connected in series in a circuit, where we have what? A light bulb as an example of a resistor or a type of resistor. And we said that the unit of measurement for resistance is ohms. Are we together? The unit of measurement for resistance is ohms. And we talked about the total voltage across the battery in a series circuit, right? We said that the total voltage across the battery is equal to the sum of the voltages of each resistor in a circuit. And we have talked about what? That resistors connected in series are potential difference dividers, right? They divide the voltage. And also the current flowing through the circuit is the same throughout in a series circuit. Meaning the reading that you get what? From ammeter 1 is the same as the one you get from ammeter 2 in a series circuit. And we said that when additional resistors are added in series, the current strength will decrease while the total resistance will be increased, right? And now, I hope you become ready for our next lesson, which is parallel circuits, right? So now, and right there at this slide, observe the differences between series circuits and parallel circuits. Then we'll talk more about parallel circuits in the upcoming lesson, right? So from me to you now, thank you very much.